We're going to go over fraction, multiplication, and division. So with fraction multiplication, if you have a over b times c over d, then that's going to be equal to a times c over b times d. So we say we multiply a numerator straight across, or multiply denominator straight across. If you can simplify by breaking it down into prime factors, then you can do that as well. All right, so on example 2 here, we have 11/3 times, and then in parentheses there's a negative 9 over a. You want to make sure you put that negative 9a in the numerator, so we're going to put it over 1. And so another way to write it would be 11/3 times, and then where do I want to put this? Well, I can make it negative 3 times 3 times a. Those would be the factors of negative 9a. And then I just am going to write it over 1 because the denominator is understood to be 1 when there isn't 1 there. Okay, so I can cancel this 3 with this 3, and then I can multiply what's left. So I'm going to get a negative answer because I have a negative times a positive from the beginning. And then 33a in the numerator over 1. Now we wouldn't usually write it that way. Oh, yeah. Okay, so because it's a 1 in the denominator, we would just write negative 33a. Now you may be wondering about that negative sign, and when we're working with fractions where that negative sign goes. I'm going to talk about that. I think it's coming up in a little bit. Okay, so reciprocals. Well, what a reciprocal is, if you have a over b, then the reciprocal it's flipped over, so it's b over a. Okay, so whatever your fraction is, if you want the reciprocal, the numerator becomes the denominator and the denominator becomes the numerator. So now we're going to talk about fraction division. Fraction division works like this. If you have a fraction divided by another fraction, then what you do is you rewrite it as a multiplication problem. And you keep the first fraction the same, change it to multiplication, and then you use the reciprocal of that divisor, or the second fraction, the one after the division sign. So we would change it to a over b times d over c in this case. So you use the reciprocal, and then you follow your multiplication rules. So now we can do an example. We have a negative 7 over 27. And I'm going to change that division to multiplication, times, and now I'm going to use the reciprocal. It'll be a negative, I'll put it in parentheses, 36 over 35. Now you have to make sure you change it to multiplication before you do any canceling. Don't try to cancel when it's in the division stage because that'll be wrong. So you have to change it to multiplication, and then you can use the multiplication rules. Now we know, let's work on this problem here. We know a negative times a negative is positive, so our answer is going to be positive. So if I want to drop the negative signs, I can. I can think of it as 7 over, now 27, how does that break down? Well, 9 times 3, or 3 times 9, and 3 times 3. So the prime factors are 3, 3, 3. So 7 is prime. I'm not worrying about the negative signs. There's a lot going on in this problem. I'll try to slow down a little bit, but I know it's going to be positive because negative times negative is positive, so I don't have to worry about that. Now, what about the 36? Well, how does that break down? 36 is 4 times 9. You can do factor trees, or there's other ways to do these problems, but I think this is usually the easiest way to see the problem, and I think it's less confusing. When you start canceling, I mean, I'll show you another way to do this problem at the end. Okay. And then 35 is just 5 times 7. So 5 and 7 are both prime. Okay. Whew. Okay, so we established that this is going to be a positive answer, a positive number. We've broken the numerator down into prime factors, the denominator into prime factors for both of the fractions. And now we can say, hey, if there's one in the numerator, it can cancel with one in the denominator if they're the same. So the 7s, they're out. 3, out with one of those 3. That 3, out with one of those 3s. And by doing it this way, you won't miss anything that could cancel. That's one of the beauties of doing it this way. So what do I have left in the numerator? It looks like I have those 2 2's. 2 times 2 is 4. Let me write the 2 2's, and I'll do the answer next to it. And in the denominator, I have a 3, and I have a 5. So final answer is going to be 4/15. Now, you might have questions about my little arrow there, my little double kind of. I don't want to use an equal sign because I don't want to make it an equation. These are expressions, so that's just my little symbol that says, hey, I'm going to put my next step over to the right. So that's all it means. In case you wondered, I use that frequently. Now, we could do it a different way. We could say 7/27, I'll make it negative, times -36/35. I still have to change the division to multiplication. But sometimes people like to do this. Oh, 9 goes into 27 3 times. 9 goes into 36 4 times. And 7 goes into 7 once. 7 goes into 35 5 times. And that's all fine. That's good. It all works. Sometimes people refer to it as cross-canceling. They don't actually have to be across from each other. You just have to have one in the numerator and one in the denominator. And then they say, okay, 1 times 4 is 4. 3 times 5 is 15. It was a negative times a negative, so it's going to be positive, and they get the answer that way. I'm fine with that. Sometimes it can get a little messy that way, and sometimes you might miss a factor, but you could always reduce it from, the answer that you got there. If there were more to reduce, you could do it that way.